Okay, so welcome to all of you. We got a good group here: Tammy and Ozzy, Joy, and 707 person Muhammad and Chase and Dimitri and Corey, and hopefully we'll get a couple more. So the plan today is we're going to be doing chapters 4 and 5. It sounds like a lot, but first, we don't do all of the chapters. We only do some of it. And second is, I think they're the easiest chapters in the whole book. So it's not a brutal week, even though it sounds like it. So that's the main thing. What I'm going to do is I'm going to work on a lot of problems. That's the main thing. I want to remind you a few things. The first thing is that you should be thinking about your projects. It's been great. I've been looking at the project discussion forum, and some of you have already, identified what your survey question is. Working out great. I'm here to help you out, but if you don't, post to get help, then I won't know to help you. So again, you should be working on your projects. Of course, you should definitely have partners by now, so you don't worry a lot. But you need to have a partner. It is an absolute requirement of the project. And then what you want to do again is post your idea, and I'll help you in either minor refinements or major refinements. Okay, or I'll just say great. But usually there's some refinement to be done. And I'm here for you. I check every day, usually several times a day, to make sure that you're set. Oops, the light just went on. I got to move around. There we go. So let me ask you, are there any questions about anything? This is your chance. And as I always want to remind you, the webinars are the best time to have instant responses to questions, because we're here.
How many stratifications should we have?
How many stratifications? So when you're saying stratifications, so for example, if you can do ethnicity, great, ethnicity. And then I wouldn't go too many. I wouldn't say, well, there's Chinese and Japanese and Korean and Mexican and I don't know, name them all. I'd stick to maybe 3 or 4 different categories if you can do some ethnicity. Otherwise, it gets way too complex. So it doesn't, this is elementary statistics, just want to remind you. So definitely don't do different types of categories. So you don't
only
want to,
one category.
Definitely. You don't want to stratify, say, by income and ethnicity.
That's what I was trying to find out. Just one category, and then limit those categories, divided into just 2 or 3 ethnicities, but just one category.
Exactly. Otherwise, you're just making it hard, and you don't need to.
That's wonderful.
In the real world, you'd probably do more, but this is a class.
Great.
I'll be honest. This is a course. In the real world, you do multiple stratifications, but then you have money in the real world. If someone's paying you a lot of money here, instead of pretending like someone's paying you money. So that's a good question and an important one, because a lot of people are dealing with that. One of the things you must do is research to see the percent of each of the types in the population. So you have to identify the population, what is your population. Then you also have to make sure that you, in your paper, in your bibliography, usually at the end, you could do it in the middle too, but you need to have your source cited. Okay, and that could be a link. I'm not like really fierce on exact citation and how you do it, but you do have to cite, because that's good writing. Does that make sense? Okay, any other questions? Are the tests we take timed? The midterm and the final are timed. Those are 2 hours each. There's a lot of reasons for that. One is that a lot of testing centers charge per hour. If I let you have 5 hours, it gets too expensive, and that's not fair. And I don't want. I definitely don't want to say, well, if you happen to be rich, then you're going to pass my class, but if you're poor, forget it. I don't do that. Everything else is not timed other than you have a midnight deadline to turn everything in, whether that's Thursdays for your initial discussion post or Sunday for everything else. So that's in a way timed, but a different kind of time than you're probably thinking. Other questions? Okay, if there's no questions, I want to jump on. I like to start at least with a real life situation. So I hope you have all heard about climate change. If you haven't, then I don't know where you've been. And politically, there's debate about it, but I want to talk about it scientifically a little bit. And I'm going to share an article with you, and we're going to do a little probability. Because, again, this is a statistics class, and probability is a big part of statistics. So let me share my screen. Go find it. Okay, so you should all be able to see this. And I like this particular site because they had some data to look at. So what this is the planet's temperature is rising. So the question is, are we sure it's rising, right? Or maybe we've just had, a few years, randomly things will happen, and it's been warm lately, right? Maybe we've just been unluckily warm, okay? So what I want to do is take a look at that, and I'm going to scroll a little bit until we see a chart. Okay, so this is a chart, okay? And if you look at it, it kind of ends now. And I'm going to go back, say, 50 years. Okay, so if you go back 50 years, I hope you can do that maybe in your head, but definitely with a calculator. What year would that be? Again, not a trick question. That's not supposed to be too hard. And hopefully it's in here. So what year would that be if you go back 50 years? Okay, so 1969. And if you look at 1969, so notice between 1969 and today, that's 50 years. And out of those 50 years, 47 of them have been above average. Is that clear? In terms of temperature. Okay, and this is pretty standard. They've done lots of measurements. There's not a lot of debate about whether the measurements are correct. That's pretty clear. So the question I have, and I'm going to write it down, and you should too, by the way, is we want to say, well, maybe if you go back 50 years, maybe that can happen, that 47 or more of them could just be warm by chance. So what I want to look at is, I want to say, what is the probability that if you randomly have 50 years, that at least 47 of them will have temperatures above average? And see whether maybe this is just random chance. Because if it's pretty likely, then you say, well, maybe it's random chance. What's all the concern? Any questions on that? If it's very unlikely, then you say, aha, we got a big red flag. Let's lift the red flag. Let's figure what's going on and deal with it. Any questions on that idea? Okay, so what we need to do is we need to find that probability. And the way you're going to have to find that probability is we're going to use our calculator. And there's a special way of doing it. There's a special type of probability that satisfies. And this is called a binomial distribution. What a binomial distribution is, what it means is that you're doing many trials. So in this case, we're doing 50 trials, 50 different years to play around with. You're doing many trials at which each trial has the same likelihood of success. So what is the chance at kind of any random year that you're going to have above average temperature? That's supposed to be pretty easy, by the way. Not a trick question. What's the chance in one year, any specific year, that you'll have above average temperature? I'm looking for a number. It's a probability. What's the probability that you'll have above average? One would mean there's a 100% chance that you can be above average, and that's not true. Does that make sense, Chanel? Yeah, so what's the chance that you'll be above average in any given year? Yeah, 50, except the way we write it is 0.5. Yeah, probabilities are always between 0 and 1. So you don't want to use percents. Okay, so 0.5. Good, Mohammed. Okay, so that's the first thing, is we know that every year you have a 0.5 chance of being above average. So what we're going to do is say, well, what is the chance that we're going to have at least 47 of those out of 50? And this is a very special kind of probability. Whenever you have multiple things that you're looking at, each one has the same chance of happening, and you want to find out the probability of having either more than or less than or at least or at most a certain number, then that fits a binomial distribution. Okay, now one of the kind of bad news is, and you can blame those Texans, you know what I'm talking about when I say blame the people in Texas? That's your calculator. So the calculator made it so all it can handle for most of their calculators is a less than or equal to. So what we need to do is we need to turn more than 47 into a statement that has a word less than or equal to. Any questions so far? So if you, for example, write down, okay, in fact, I think what I'm going to do is I'm going to reshare my desktop. I've already put in a question, but I realize I'm going to, right below it, just ignore what's up there, and we're going to do a little scratch work. And let me grab that. Okay. Oh, how do you know it's one? Oh, there's always a 50% chance that you're above average, because that's what average is. Average is in the middle. And I'm using median for average. Yeah, so there's always, if what's a percent chance that you're above the middle, that's 50% chance. Okay, 50% chance you're below the middle. That's what middles are. Okay, so ignore this. We'll get to that in a little bit. We're going to do another question after this one. But I want to write out some stuff. One thing I realize is I put it in chat, then the YouTube doesn't get it. So I'm doing it in Paint. And YouTube does get Paint. Okay, so I'm going to write down some numbers. 45, 46, 40, 47, 48, dot, 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 oops, dot, 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 and let's put some dot, dot, dots before the 45 also. Okay, any questions? So we want to find out the chance that we're at least 47. What numbers are at least 47? So you can put in the chat box some numbers that are at least 47, because I know some people have trouble with this. Okay, yeah, I'm seeing both sides. Okay, so the way I like to remember it is I hope you all know that you have to be at least 21 years old to be in the bar. Do y'all agree? So if you have to be at least 21, being 19 is not okay. Well, if you have to be at least 47, being 45 is not okay. Is that clear? Okay. Now, if you're 21, can you go to the bar? If you have to be at least 21? Yeah. Yeah. So at least 47, what that means is 47 and above. So I'm going to circle that. Like so. Any questions so far? So now what we can do is we can say that the probability that x is greater than or equal to, because that's what we want, 47, well, the calculator can't handle greater than or equal to. It can only handle less than or equal to. So we're going to use the rule of complements. That's 1 minus. And what is the complement of greater than or equal to 47? How high do you go? Okay, 53 is greater than 47, where complement means the other side. 46. So 1 minus the probability that x is less than or equal to 46. Any questions on that? Any questions? Okay, so now we can jump to our calculator. So I'm going to do a new share and pop in the calculator. By the way, you're not going to be able to do this by hand. The calculator is an absolute must for this class. So what I'm going to do is I'm going to go to second distribution, which is this VARS button next to the clear. If you have a calculator, I recommend you doing it with me. Then I'm going to scroll down, pretty much actually, to binom CDF. And you hit enter. I'm going to let you know the older calculators are a little different. In fact, my long video has the older calculator one, so you get to see both. It's going to just say binom CDF, and then you put n, comma, p, comma, x. And n is the number of trials. In this case, it was 50. P is the probability of success, which is 0.5. And the x value is 46, because we're doing 1 minus the probability that x is less than or equal to 46. Any questions so far? So now I'm going to scroll down. I'm going to paste. So if you're using the older style calculator, it's going to say binom CDF, and you just type in 50, comma, 0.5, comma, 46, and the parameter. And then I hit enter. And you'll notice this is 1. Now, some of your calculators will be slightly different, but it's going to be very, very close to 1. How you come to P? Oh, so P was the 0.5 because there's a 50% chance of being above average. Does that make sense, Mohammed? So P is the probability of what we call success. Success doesn't have to be a good thing, but it means that we successfully got what we were looking at.
Yeah, actually, I'm also using the calculator, but I couldn't come to. I followed to.
Oh, how do you get there? Hit the down arrow. Try hitting the down arrow.
Yeah, it doesn't work.
Try hitting the enter. See if that works.
No.
This should work. Is it a TI-84?
Yes.
Really?
TI-84.
Yeah, that should work. I have another one here. I could do it on this one, but I've done it on lots. So I'm not sure what to tell you on that one.
Start over.
Yeah, that one's a hard one to help you. Yeah, it's the same one I've got.
I cannot.
So you type in the number of trials, which is 50.
Okay.
Then hit enter. Try hitting enter after 50.
Should I 50?
And then the cursor should go down to P after you hit enter.
Yes. Yeah, I'm good.
Then you hit 0.5. Got it?
What should I put for P?
0.5. Do you see I have 0.5 here? 50, comma, 0.5, comma, 46. And that's because P is the probability of the occurrence happening, of the single occurrence.
Okay.
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 Now remember, we're looking at 1 minus this probability. I hope you don't need a calculator for this. What's 1 minus 1?
0.
Yeah. And actually, the probability is not exactly 0. It took me a lot of work, actually, to come up with the exact probability. And this one you can trust me in. It's not exactly zero because it could happen, right? But let me just put it this way. The chance of it happening is not even 1/100th as likely as the chance of winning the lottery. So it's not even 1 in 10 billion chances. So just to give you an idea. So what does that say if it's that close to zero? If it's 1 in 10 billion? Yeah, that means climate warming, that means the warming is truly a trend and not just a random event happening. Is that clear? And the way statistics works is it does not tell you causation. Remember that. What it tells you is something's happening. So I'm not going to get into the details, but at that point, that's where you go to science. And you say, are there any science things that have happened in the last 50 years that could cause the temperature to rise? Because something caused it. Okay, and what they have found is there's only one thing that scientifically could do this that we've actually measured. Any guess on what that is? Yeah, us, and in particular CO2. And that's chemistry, so I'm not going to do that. But I could. That was my minor, and I've definitely learned all about it. Okay, so basically the chemistry showed it. There's other things that could happen, but they didn't. There's certain things that happen in the sun that could cause it to warm up. But we've been looking at the sun, and it hasn't happened. You know, you could have erratic behavior of the sun causing us to warm up. But that hasn't happened. So pretty much the CO2 is the only thing that we have found that could make this happen. Okay. Any questions on this? Okay, what I like about this is you probably all heard about climate change. You've all heard the scientists are in agreement. And now you're actually starting to hopefully see why. And this is how they make decisions and make conclusions, is they look at data, they look at probabilities, and based on the data and the probabilities, they see if something's going on, and then they use science, chemistry or physics, to explain what's going on. Okay, the one thing you don't want to use is politics. Okay, that never works. But you do want to use science and math, and that's how you should make decisions about, especially things that are scientific. Any questions on this example? Okay, so let me reshare. Okay, and I think that's the first time I've done this with you. Use paint. I'm going to use paint a lot from now on because what's happening is that our questions are going to get more complex. Okay, I don't know if it's necessarily harder, but it's definitely going to be complex. Okay, why is it called binomial? That's a good question. Bi means two, and remember that a binomial distribution can only happen if it's a yes or no question. So was it above average or was it not above average? Does that make sense? So that's where that comes from. Is the bi means two, the nomial means number. So there's two different numbers that can happen, or names, I guess, yes or no. And in math, we call those ones and zeros. So that's where it's coming from. But again, I'm a math guy, I'm not an English guy, so it's best guess. But I can't think of anything else why they call it that. Math people are pretty logical. Okay, so now what I want to do is answer the next question. Now you're not going to ignore it, now we're going to read it. Okay, so I have a little question for you. A car salesperson gives out a $10 gift to every customer who drives who test drives a car. By the way, is this realistic? Does this happen sometimes at car dealerships? Okay. I'm seeing a no. I'm seeing some yes, not to me. Okay. The answer is yes. The answer is yes. Not always, but they definitely do this a lot. They try and get people in by trying to give a little gift if you come and test drive a car. Okay. Used to be a toaster. Yeah. So there's your gift. Okay. 12% of all customers who test drive a car purchases a base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Write down the probability distribution function for the salesperson profit, find the expected value and standard deviation, and then interpret the expected value. And I'll probably interpret the expected value also. Is this a lucrative job? Something I've learned is not all of you know what the word lucrative is. Who knows what lucrative means? Put in the chat box what it is. Yeah, worth it, right? Is it a job that's going to make money for you? Because that's what you want, and pretty good money. Okay? Is it a job that you might take if you don't mind doing the car sales in terms of money? Okay? So notice a couple things. The first is, unlike the other, like binomial, this one has not just one choice or two choices, yes or no. This has multiple choices, and they're numbers. Do you see that? And not only in numbers, but we can list all the answers. Okay? Do you remember what you call it when the survey question has number answers and you can list all the possible answers? We had a word for that. Quantitative is when you have number answers, but if you can list all the possible numbers, there's a different word. And remember? Now, qualitative is when you don't have number answers. Give you a chance. Going once, going twice. We call it discrete. We call it a discrete distribution. So discrete means that you can list the answers. So in this case, the possibilities are we can have a $200 commission, a $300 commission, or we can have no commission. And in terms of profit, remember we're giving a gift out. Yeah, discrete versus continuous. Mohammed, it's continuous. Okay, so in terms of profit, notice if you're getting a $200 commission and you have to pay $10 for the gift, your profit is $190. Any questions on that? Okay, so now what we need to do is we need to make a little table. So hopefully this will work. I haven't done this one too much, so I think this will work. Well, let me do a second one, or I have to re-grab it. Nope, I have to click it again. So I'm going to make a little table. Maybe I should use a pen. It would have been faster. Sorry. And that's good. And then what I'm going to do is I'm going to, in the table, let's do it in red. The first row is going to be called X. And then the second row will be P of X. And we've seen P of X before. What does that mean? Yeah, probability of that value of X happening. So now we look at the different X's that can happen. Well, we can get the $200 commission, but we got to pay $10, so that's $190. We could get the $300 commission, pay $10. So we're talking about $2.90. Is that all that can happen? Is there anything else? Yeah, that's what usually happens is no sale. And if you have no sale, what's your profit? Yeah, -10. -10. Notice the profit is the revenue minus the cost. Revenue is 0. Cost is 10. So that's 0 minus 10 is -10. So I'm going to put -10. And then I put the probabilities for each. So the first probability, the probability of profiting 190 is 0.12. Then the probability of profiting 290. By the way, this is a mistake a lot of people make. 8%. How do you write that as a decimal? Yeah, 0.08. Don't make the mistake of going 0.8. Don't forget, you're going to move it over twice. All right, how do we find the probability of ending up with an x value of -10? Yeah, except with decimals. So what we're going to do is we know the probability of something happening is 1. And if we subtract the other two, that'll give us what's left over. So we're going to take 1 minus 0.12 minus 0.08, and that's 0.8. Any questions on that? Okay, so we've now written down what's called the probability distribution function. We've written it as a table. So sometimes we call this the probability distribution table for the profit. Any questions on creating this table? Okay, the next step is the expected value and standard deviation. I'm going to just write down these numbers: 190, 290, -10, 0.12, 0.08, 0.8. I recommend you writing them down too, so that you can keep track, because we're about to lose it, because I want to share my screen with the calculator. So now I go to the calculator. Okay, so what I got now is our calculator. Let's clear what we had so you don't get distracted. I'm going to go to Stat. I'm going to go to Edit. I'm going to go to L1, go up and hit Clear and Enter. Never hit Delete, please, or you'll really be crying. Then I'm going to hit the right button up and then Clear and Enter. Then in L1, I'm going to put my X values: 190, 290, and -10. Just a note, below this 3 is a negative. Next to the 6 is not a negative, that's a subtraction. And don't get them confused. It's another thing that Texas could have done better on. So we have -10, and I hit Enter. Then I'm going to go to L2s, and I'm going to write the probabilities. So we have 0.12 for the first probability. We have 0.08 for the second. And we have 0.8 for the third. Are there any questions so far? Okay, so now I'm going to hit this. Now what I need to do is I need to find out what the expected value is in standard deviation. And the way I do that is I hit the Stat button again. I go to Calc. We've gone to the screen before. And I'm going to do one var statistics. And our list is L1. You can go second one if it's not already there. It was for me, but I figured I'd show you how to do it. And hit Enter. And then our freq list, which is the frequency list, is L2, and that's second 2, and I hit Enter. Just a note, if you have the older style, Then when you hit one var stats, it's going to say one var stat with a parenthesis. You type second 1, comma, second 2, and then end the paren, and then enter. And you should get the same thing. Any questions so far? Okay, so our two important numbers. This x bar is the expected value. So the expected value is 38, and sigma x is the standard deviation, which is 98. Any questions on that? For the older calculator, what you do is you go to one var stats, hit enter, then you hit second 1, and then comma, and then second 2, and then close the parenthesis and hit enter. Does that make sense, Lucas? So again, one var stats, and then second 1, comma, second 2, enter. Okay. Any questions at all on the calculator before we leave it? All right, so let me go back to the question. Okay, so what we need to do is we want to interpret the expected value. So let's do that. Leave some space, so you're going to be writing a lot. So what we can say is that if many customers come for a test drive, then it is very likely that the average profit per customer will be close to. And what we got was $38. Oops, dollar sign. Per customer. Okay, so I want to let you know some important things. In this sentence, there are some not optional pieces of the sentence. I wonder if I'm able, well, it's okay, I'll just underline. All right, the word many, that's not optional. Likely, not optional. Average, not optional. Close to, not optional. Okay, so when, notice I'm not saying if, when I ask you about interpreting the expected value, these words need to be there. Any questions at all? Any questions at all on this explanation? Any questions? Okay, just a note, the standard deviation was 98. Is that large or small? What do you think? Okay. No idea, small. Okay, so think about it. The profit, the average profit is expected to be close to, or likely to be close to $38. And our standard deviation is 98.
I'll eat it later. Listen to this.
So notice the standard deviation is much bigger than the expected value. Does that make sense? Okay, so this is a large standard deviation. So that means that, yes, $38 per customer. By the way, has any of you been a car dealer before? Any of you had that job? Okay, my brother did it actually when he was, I think, some summer between in his college time. It might take, I don't know, 20 minutes or so to test drive with someone. Well, imagine 20 minutes, you're making $38 an hour. That's not bad, is it? For a no education job. Okay, but with the standard deviation 98, it means, especially towards the beginning, you might end up losing money. So with the high standard deviation, the idea here is that you would want to make sure that you have some money in the bank in case you're not making any money at the beginning. Okay, if you do it for long enough, you'll average very close, or you're likely to average close to $38 per customer. But for the first couple customers, it may not go so well. Any questions on what the standard deviation tells us? Because it might fluctuate way down. Any questions at all on that?
I'm sorry, Professor. I'm not totally understanding how we know how one number relates to the other as far as standard deviation. So if it had come back $45, then that means it would be much more lucrative. But if it had come back $138, then that means that it isn't, right?
For the standard deviation?
Yes.
Actually, the standard deviation has nothing to do with whether it's lucrative.
Okay, so I'm trying to see the correlation between the two values and why we can take one, what you told us the standard deviation tells us. How do we...
Right. So the standard deviation tells you the risk.
The risk.
The risk of losing money or gaining a lot of money.
The risk of this outcome happening.
Not this outcome, of losing a lot of money. So in other words, you could go down. If you go down $98, you're in the negative. Does that make sense?
Yeah.
That's really bad. That's a bad day.
Sure.
If you go up $98, you're up way high. That's a really good day. Okay? Or a good couple customers. Do you see that?
Sure.
So what the standard deviation says is that if you have a high standard deviation, you don't know if with just a couple customers you're going to have a lot of money or no money or negative money.
But then the law of large numbers kicks in, and over the long average, that would be the standard deviation. Is that what?
Over the long average, then the standard deviation is irrelevant. You're making $38 per customer on average.
Okay.
With very high likelihood.
I'm just struggling a little bit to understand what we get out of the standard deviation, what its purpose is.
So it's telling you the risk for the first customer.
Okay, thank you.
Not many customers, but the first customer. Maybe the first two, but definitely not many customers. Does that help? And we'll be able to quantify that in another couple chapters.
Okay, thanks.
3 chapters, actually. And then we'll have some formulas for deciding on how many you really need. Okay. All right. Any other questions? Okay. Let's do another one, another problem. Let's go to, so I'm going to erase this guy. And let's pop another one in. Takes a second. Okay, so 21.2% of high school seniors have used marijuana. A study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana, and assume those students are seniors, by the way. Okay, so is this statistically significant? Find the probability of at least 49 of 200 have tried it. Okay, so let me explain. We're going to find this probability, and then I'll talk about statistically significant. Okay, so if we want to find the probability that at least 49 of the 200 have tried it, what do we have to do? What kind of question is this? And that's one of the hard parts about this class, is deciding what kind of question we've got. Any thoughts? If I don't get anything, I'll tell you, but hoping to get something. All right, let me tell you, this is a binomial distribution question. Okay, so it's a binomial distribution because either someone has tried marijuana or they've not tried marijuana. You can't kind of have tried marijuana. It's either you did or you didn't, right? Do you agree? Yeah, Clinton, I'm not going to go there. Okay, so it's a yes or no, and we are looking at 200 students. So that means we're repeating the experiment over and over again. Okay, or we're doing a survey. That's what repeating the experiment means. And we want at least 49. So very similar to what we did with the global warming one is if you want at least 49, we're going to have to use the rule of complements. So if we go ahead and we write down the probability, oh, that's really small. Just a minute, let's try again. That could total effort. There we go. Okay, so now we're going to say probability that we have at least 49. What's the inequality for at least? Do you remember? Any of you remember? Yeah, greater than or equal to 49. The calculator doesn't do greater than or equal to, so we're going to have to do the rule of complements. So that is equal to 1 minus, and again, if you write down 47, 48, 49, 50, 51, greater than or equal to 49 is 49, 50, 51, etc. The complement of that is 48 or below. So that's going to be the probability that x is less than or equal to 48. Any questions on that? Okay, so now we go ahead and we get our calculator out. Again, I'm going to do this a lot faster because we've seen it already. So let's clear what we had. So now what we're going to do again, we're going to go over to second distribution. Scroll down a bunch. Binom CDF. By the way, binom PDF is for exactly equal to. Okay, I'm not going to have time to do one of those, but that's for exactly equal to. But binom CDF is what I want. Our trials were 200 trials. The probability of success was 0.212. Oops, what just happened? 0.212. Because 21.2% of high school seniors have tried marijuana. Remember that? The X value was 48. And I paste, and I hit enter. Any questions so far? Okay, but that's not the answer because I got to subtract from 1. So you get about 0.85, but if you subtract from 1, what's 1? 1 minus 0.85? You may not need your calculator. You might be able to do it in your head. And if you use your calculator, that's fine too. Yeah, 0.15. So that is equal to 0.15. All right, so let me give you what statistically significant means. What that means is it's a small enough probability that you say, well, that is pretty rare. Any questions on that? And the main number that people use for that borderline number to decide what's rare is 5%. So if you're less than 5%, then we're going to say it's statistically significant. What can we say here? It's not. So notice that (0.15) is greater than 0.05, so it is not statistically significant. What about the climate change example? That was a real example. Was that statistically significant? What do you think? Yeah, very much so. It was extremely strongly statistically significant because our number was less than 1 in a billion, less than 1 in 10 billion, actually. So that's certainly less than 5%. Any questions on this example? Okay, so now it's time to move on to the next type of problem. What we've been working with are discrete distributions, right? We either have yes or no, which you can think of 0 as 1, 0 or 1, and then, or we also have distribution tables, and that you could list them. Now we're going to work with the continuous distributions. So I'm going to draw some pictures first. There's my brush. Black. Oops, that didn't work. Let's try one more time. That one. Okay, first thing is that when you have a continuous distribution, you can't make a table. Any guess on why? Any thoughts? It's not even possible to make a table. Yeah, you can't hold all the answers because by definition, you can't list the answers. If you can't list the answers, they don't fit in a table. So we think mathematically. What you can do is draw a graph. And the graph I'm going to show you. Might look something like that. Okay. And that is a probability distribution. And the way you define probabilities when we have a distribution function is by area. So let's suppose you want the probability between here and over here. Then what we do is we find the area under the curve in between those numbers. And that area is the probability that x is between the two numbers. Might be a is less than x is less than b. And I guess I should put an A and a B. Any questions on that idea? Okay. The good news for you guys is that we don't know how to find, or you don't know how to find areas of functions that look like this. Okay, my guess is most of you don't. Let me ask you, just type in a yes if you have had calculus before, or if you're in calculus. And everyone else, just leave it blank. Okay, I'm not seeing any yeses. Okay, so without calculus, you can't do this. But there is one example. There is one example that we know how to find the area of without any calculus. In fact, with basically sixth grade math. What's the one thing that you can find an area of? Okay, that would look like something like this, but not so like weird looking. Any thoughts? What's the easy one? The area of a square. I'm going to go a little bit more general. Rectangle. Yeah, Ozzy. Rectangle. So we know how to find the area of a rectangle. So because of that, that's going to be the example for this chapter, because at least we can do that one. Okay, if the distribution is rectangular, which means flat, right? So if it's flat, because then it's going to look, let me draw it. Then instead, it'll look like that. And hopefully you all remember, how do you find the area of a rectangle? What's the equation or the formula? Yeah, base times height. So we're going to be using that a lot. Any questions so far? Okay, so I'm going to erase this, and I'm going to pop in a question. Okay, it's actually going to be two questions. All right, so suppose that the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. So uniformly means it has that flat distribution. Okay, if a randomly selected MATLAB user is observed, find the probability the student will spend between 30 and 70 minutes in the lab. Any questions on the question? Okay, so what we need to do is we need to draw a picture. And by the way, just to let you know, on the test, you get a problem like this. If you don't draw the picture, you don't get full credit. I'll take a lot of points off. So I need to draw the picture. So let's do that. Go brush. I think I'll make it black. So as I mentioned, if it's uniform distributed, it means that it's flat, a rectangle. Then we can put in our numbers. So 10 is the low side. And 120 is the high side. And what I need to do first is I need to find the height of this rectangle. But here's the thing. If I said the area is the probability, then what must the full area be? What must the area of the full rectangle, what would that be? I'm looking for a number. Not 110, simpler than that. Close, but 1. Okay, you might be thinking of percents, but remember, we're using decimals. Okay, so 1, because the probability of something happening is 1. So that means that 1 is the area. And let me just write down the basic formula that I said already. And that was that the area is equal to the base times the height. Any questions on that? Well, that is equal to the base, which is 120 minus 10. The height, I don't know yet. I'm just going to call it h for now. And that area is 1. Have I lost anyone there? All right, now we're going to do a little math. We've got to solve for h. So what do you get for h as a fraction? Yeah, h will be 1 over 110. Okay, because 120 minus 10 is 110. We divide 110 on both sides. Any questions on that idea? Okay, now I can start answering the questions. The first is, what's the probability someone will spend between 30 and 70? So let me draw that. So 30 might be around here. 70 might be around there.
Fucking gay.
And we want that probability.
Fucking hate school.
So that's 30. And then 70. And the probability is area. So again, the area is the base times the height. And the base times the height is equal to the base now is what? What's the base of this red rectangle? Yeah, 70 minus 30. And the height we've already found out was 1 over 110. Any questions so far? And that's what, 40 over 110 or 4/11ths. Any questions at all on the first part? Any questions on this? All right, now for the second part. Okay, for the second part it says, find the first quartile for the time that students spend in the math lab. Okay, so what I need to do, let me, I think I'll need to redraw the picture.
Oh, he's a skier. Gay.
So there's our picture between 10 and 120. And then 120. Yeah, no, I get that you're not talking to me. I know you need to hear me. We were hearing someone else in the background. And always a good idea to turn your mic off if you don't have something important to say. Okay, so 10 between 120. Now, first quartile. Do you guys remember what first quartile means? Yeah, it means 25% of the data is less than that number. So I'm going to go and draw some more in this picture. So what we know is that the area of this piece is 0.25. Any questions on that? I just want you to notice 0.25 is the area. It's labeled kind of up high. It's not on the x-axis. It's not an x-axis number. It's an area number. The x-axis, if you want, you can call it x, because we don't know it, but we're going to try and find it. Any questions on that? Any questions? All right, well, now we can use this area formula again. You know, the area is 0.25, and that's the base times the height. So let's write that out as an equation. So we can say 0.25 is equal to the base. What is the base of this rectangle? Of this red rectangle that I just drew. Okay, it's a little complicated. Okay, the one, not the one I originally drew, the new one that I just drew. Okay, notice that the farthest left is 10, the farthest right is x. So the base is x minus 10. Any questions on that? Everybody lost you? Okay, the height is 1 over 110. It's the same height as we had before. All right, well, we need to solve for x, so we need to do a little algebra. So what should we do to both sides? Any thoughts? Solve for x. Yep, definitely want to solve for x. And so what's the first step on solving for x here? Yeah, we're going to multiply left and right by 110. And when I multiply left and right by 110, what I get is 0.25 times 110 is equal to x minus 10. All right, what's the final algebra step we need to do? Not subtract 10, but yeah, we need to add 10 to both sides. So we're going to add 10 to both sides. So I guess I should remind you, this is a math class, so we do math. And we get 0.25 times 110 plus 10 is equal to x. And you can put that in a calculator if you want. And what do you get? 37.5. And that looks about right, doesn't it, from the picture? Any questions on this example on finding the first quartile? Okay, this class suddenly got a little more mathy, didn't it? And we kind of ebb and flow in terms of doing math. So this is kind of a mathy chapter. All right, I want to do one more quick example. So let me ask you, is it okay if I erase what I've got here? Okay, so I'm about to erase. Yep, it's definitely recorded. So far, I've never had it not work, which is good. I always worry, what if it doesn't record? But it always does, so that's good. Erase this. I'm going to pop another question in. This one's going to be very different looking. Okay, suppose that the number of ounces of water people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces. And the number of ounces of water that students use to fill their bottles, like this guy, in the drinking fountain, is uniformly distributed between 4 and 16 ounces. You watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water bottle is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Okay, you're not ready to answer yet. You can try. It might be Preston, but it's just a guess if you're just answering now. We have a lot of work to do here. So the first thing is, what does this look like? What kind of problem that we've seen before is this kind of like? From a different chapter. Any thoughts? I'm not seeing y'all jump in, but okay, if you don't know, doesn't it look like a z-score question? Because the z-score tells you how unusually small something is. Does that sound familiar? Okay, so it might not, I don't know, but let me remind you of the formula. That is z is equal to x minus mu over sigma. Remember doing those problems? Chapter 2?
Yeah, no, I don't remember.
Been a little while, but not that long. Okay, so this is that kind of problem. But we need to find mu and sigma. And to do that, we're going to have a formula, 2 formulas, one for each. So the formulas are mu is equal to a plus b over 2. So it's just the average of the high and the low of the distribution. Is that clear? Okay, sigma is something that I don't expect any of you to just guess at, because it's involves calculus to figure out. It's a tough one, actually. But it's formula. And that is going to be the square root of b minus a squared divided by 12. Okay, what I'm not going to do is tell you why. Okay, mu makes some sense. Sigma is hard math that I'm not getting into. But you can pop that in your formula sheet if you need. Any questions on that? All right, so what I want to do is I want to find these z-scores. So let's do one at a time. So why don't we start out with Thorn. Thorn is first. So to do Thorn, I'll do Thorns in blue. And to find Thorn z, I guess I should put z equals. We need x. Well, x was 2.5. That was what we watched, the observed value. Minus. Now we have some work to do. We need to find the mean. Well, Thorn just took a drink like that, okay? And notice that the just regular old drinking is uniformly distributed between 1 and 8. So our mu is 1 plus 8 divided by 2. Have I lost anyone there? And 1.8 over 2 is 4.5. So I can put 4.5 right here. Any questions so far? Okay, we need to find sigma for Thorn. So sigma is the square root of b minus a squared. So b minus a will be 8 minus 1, which is 7. 7 squared over 12. Now, I do not expect you all to have this one like in your head that you can just do, but you should be able to pop this into a basic calculator. But I'll do that right now. I just use Google. And I got about 2.02. Everyone okay with that? That goes here. We could put that in our calculator. We have 2.5 minus 4.5 is negative 2. Negative 2 over 2.02 is about negative 1. Ish. Within a decimal place or so. Have any questions at all on this example so far? Okay, so now let's go to Preston. So for Preston, again, z equals Preston's x value was 5. Minus, and the mean for Preston is a plus b over 2 for Preston. And Preston's doing the bottled one, and that's between 4 and 16. And notice that 4 plus 16 over 2 is equal to, hope you can do that. Should be able to do that in your head, I think. Is 10. Any questions on that? Okay, and then Preston sigma is the square root. 16 minus 4 is 12. Squared over 12. Which is actually just root 12. And the square root of 12 is about 3.46. So now we can type in 5 minus 10 over 3.46. Put that in the calculator, which is, again, negative 5 over 3.46. And I get about negative 1.44. Or negative 1.4 is good enough. So whose was more unusually small? Yeah, so who's more unusually small? Okay, remember, being unusual means you're far from 0. Preston, yeah, Preston. Actually, Ozzy, you got it right at the beginning, but I'm sure you didn't do all that fast in your head. No way. But Preston's z-score is negative 1.4. Thorne's was negative 1. Negative 1.4 is farther from 0, so it's more unusual. Any questions? Any questions on that? Z-scores are really good for deciding how unusual something is. Is it an outlier? That's kind of the point of a z-score. Right? It allows you to compare things that aren't even of the same units, right? We're talking about, bottled drinks versus just drinking out of the drink fountain. Does that make sense? So if you just want to find out how unusual something is, then the z-score is very good for that. Does that help, Tammy? Kinda. So practice, that'll help. All right, so the last thing I need to do, I think you all know. Hopefully I can fit it in here. The secret word is many. So that's because when you're doing the expected value, many was one of those important words. That was the first important word, is that if you have many, many trials, or in this case, customers we looked at, then it was likely that the average will be close to whatever that expected value is. So many was the first word that you had to put in the expected value. So that's the secret word for today. And I made it before an hour and a half. That's always my goal. All right, so as always, what I'm going to do is I'm going to put this up to questions. I'm going to unshare my desktop. Oops. There we go. That way you could just ask questions. So are there any questions you might have? And again, this is your chance. Could be about the project, it could be about what I talked about, it could be anything. And as I mentioned, that lottery that I bought actually was a winning ticket. So I'm happy. I got a smile on my face. Remember, I did that last week. It won. So for the last question, are those all the steps we need to take to find the answer? Yeah, I mean, I didn't show you how to type arithmetic in your calculator, Chanel. I'm assuming you know how to use your calculator for, that's just basic arithmetic, nothing statistical or anything. But you find the mean, you find the standard deviation, you use the z-score formula and you plug it in. And then you decide which is farther from zero. So for the test, that is how we show our work. Yeah, I mean, everything I put, if you do what I put on the little whiteboard thing, then you've shown your work. Okay, again, you don't have to do the arithmetic on the white part because that's in your calculator. Biggest issue I'm having with the homework is deciding what formula to use. That is always one of the big challenges. Yeah, practice is the best. I'm not going to tell you that here's the one thing you should know and that'll get you all the formulas down, other than practice a lot. And the bad news is we're not done. Every week we're going to have more formulas. So keep practicing. Okay, but some of the main ideas are going to come back, which is good because that helps you practice more. Other questions that you might have? Where do you put the project question? You put that in the project 1 discussion forum. That's what you mean? Like so that I can look at it? Is that what you mean, Mohammed? Yeah. So you post that in the project 1 discussion forum. And if you look at that discussion forum, you'll see other people have already posted. And that'll help you get ideas on what works and what doesn't work. Well, I finished the whole bottle. Doing these lectures really makes your throat dry. Any other questions? And again, if you don't, we can say goodnight. Believe it or not, I'm at work right now, but here is my means of transportation home. So it should be fun. And again, I'll stick around until there's no more questions or until you're all out. But I'm happy to answer questions if you have them. Okay, have a good night, Tammy and Chanel and Mohammed. Enjoy.
I had one quick question.
Yeah, Michael, what's your question?
So when I did the word quiz for last week.
What's that? Sorry.
The word quiz?
The quiz? The quiz?
Yeah, the secret word.
Oh, the secret word quiz, uh-huh.
Yeah, when I did it for last week, I watched a YouTube channel instead of going to the Moodle. Is that how we'd find the most recent ones?
Okay, so right now, of course, you know the secret word, but in the future, what you do is you go to the module, and of course, this week isn't up yet. I'll have that one up probably tonight. If not, it'll definitely be early tomorrow morning, but probably tonight. And so if you go to the week's module and you go to the webinar, it'll say week whatever webinar. Click on it, and the video's right there.
Okay, because I typed it in. I was like, oh, yeah, I just got it right. And then I was like, wrong? What do you mean wrong?
Did you eventually get it?
Yeah, well, then I realized that I was watching the one that was it was months old, and you probably had a different secret word.
Yeah, I change the secret words every quarter. And there's something about YouTube. YouTube's great, but you can't delete videos.
Hmm.
So I can't get rid of them.
Okay.
Those will be there forever. Yeah. So it's one of these weird things about YouTube is even if you like want to delete it and replace it with something a lot better, you can't do that.
Okay.
So sorry about that, but it's a YouTube thing. But I've learned that what's good about YouTube is everybody can get access to it.
Yeah. Yeah.
It's never a problem. No one's ever said, well, my computer doesn't work with YouTube. So that's why.
Now I know.
Huh?
Now I know.
Yeah, yes, that's what you do. And you know what? If you ever have trouble, email me.
Okay.
You know, or sorry, not email me. Post in the Q&A form for that.
Okay.
I can't post in the Q&A. Say, how do you get to the whatever, and then I'll give you the link. Okay. Any other questions?
Should be all.
Okay.
Thank you.
All right. Thank you.
Have a good night.
Have a good night, Jerome. Any questions? Ozzy?
What's the secret word? I didn't write it down.
So the secret word, I'm going to put it in the chat box.
Okay.
And that was,
I think I wrote it in
Don't say
one.
don't say it.
Okay.
I usually don't put it at the very end because then people just go to the end and that's all they'll watch. I want them to watch the video.
I saw it. I put it in my notes. I forgot what I put.
Oh, well, if it's in your notes, then it's fine. Okay, other questions? Okay, and for all of you watching this as an archive video, thank you for coming in and watching, and please post on the Q&A forum if you have any questions in general, and on the Project One discussion forum if you have questions about the project, and post your project idea, and then I'll comment on it, tell you what you need to do for it. So until then, we'll say goodnight. Ozzy, I assume you don't have any questions, you're the last one here. But if not, this is your last chance. Once, twice. Okay, well, have a wonderful night.